departure. This is just to convince you that when we take into account particles with size, it's different. And what is the difference? The difference is the following. Now we will write a mu as where now it has no vector potential, no magnetic field, but it has a scalar potential, the scalar component of this 4 vector, and this A0 is a static function phi of x, which you can write as now. So what I mean is that this phi x is representing a, that is phi x is non-zero, suppose, within this boundary. The total charge of this charge distribution is Z. Therefore, this integral of rho x over this charge distribution must be equal to 0. So that the total charge, the integral of this phi over the charge distribution should give you Ze. Therefore, the rho is defined in such a way that its space integral is 1. Now what happens in this case? Now, again I will not be computing the cross section, but just to see the departure from it turns out that this is equal to I took this example because this is a number known to you. I will explain everything one by one, but now what are the various terms here? Now alpha is the fine structure constant, so this is nothing but d square over 4 pi. Forget about this for the time being. V is the velocity of the scattered electron. So I think it is velocity of the incident electron. Theta is the scattering angle. That is, this is my incident electron and this is my scattered electron and this is my scattering. So this is the geometry. An electron comes in, it is scattered and theta is the scattering. Now forget about this factor for the time being. Forget about this factor for the time being. Just note that if the velocity is very small, actually here velocity is written in units of velocity of light. So this factor, if v goes to 0, non-relativistic case, this factor is 1. So you can forget about it. Now can you recognize the remaining terms? At least by the sine 4 theta by 2 in the denominator. Does it tell you of anything? What? This is rather 4 scattering. And when this cross section was calculated, this was calculated for the interaction of alpha particle with a gold nucleus of something. If anybody remembers the value of Z for gold, I don't. So 79. So the total charge of the distribution was 79. In this calculation, both the alpha and the nucleus will be treated in a quantum field theoretic calculation if we do it blindly as point particles. And therefore, this result you will get for point line. That is, if the charge distribution was indeed a geometrical point, then you would get neither this, but this you wouldn't get if the velocity of the electron is low. You will get only this. But this f of q square gives you this represents departure